Welcome to our lesson about the Helix tool. The diameter of a helix is based on the diameter of a circle. So, before creating a helix, we need to start with a circle. Let's begin by inserting a sketch on the top plane. Activate the Circle tool and place it somewhere here with the center at the origin point. Let's exit the sketch, take an isometric view. Now let's go to Insert, Curve, Helix, Spiral. A helix can be defined in a few different ways. The first option is by pitch and revolution, next height and revolution. The third way is by height and pitch, and last is the spiral method. Let's try pitch and revolution first. Pitch refers to the height of one revolution, and currently the height is 35.5 millimeters. Revolutions, let's set it to 2. We can reverse the direction by checking here. We specify the start angle in this field. We also need to choose between clockwise or counterclockwise. We can opt to taper the helix by a specified number of degrees, either inward or outward. Next, let's look at height and revolution. The total height we specify here, the number of revolutions is 2, and the remaining options are the same. Height and pitch is our third definition method. We now have a 60 millimeter total height. 30 is the height of the individual pitch. The last option is the spiral method. This is controlled by pitch and the number of revolutions. Let's return to the pitch and revolution method. In the parameters section, we can specify a constant pitch or a variable pitch. Set the values for the variable pitch by making entries in this table. Let's create another entry of 4 revolutions of a 40 millimeter diameter, and each pitch will be 15 millimeters. Let's change an entry in the second row as well. We'll change the diameter to 80 millimeters. And let's click OK. In order to edit the helix, just right-click on the feature and select Edit Feature. Since the diameter of the helix is controlled by a circle, I have to edit the sketch that supports the helix in order to change the diameter. This concludes our lesson about the helix. We'll be applying it to a model in our next lesson.